In question 1, we have to solve the equation 2 cos theta equals to 7 minus 3 upon cos theta for theta greater than minus 90 and less than 90. So in the first step, we'll take the LCM on the right hand side. So this will become 7 cos minus 3 upon cos. Cross multiplying, this will become 2 cos square is, and then bringing the 7 cos on the left hand side. So this will be minus 7 plus 3 equals to 0. Factorizing this, we'll get 2 cos squared minus 6 cos minus cos plus 3 equals to 0. Taking 2 cos common, this will become cos minus 3. And taking 1 common over here, this will become cos minus 3 equals to 0. Finally, taking cos minus 3 common, so the final answer will be cos minus 3 and 2 cos minus 1 equals to 0. So cos theta will be equals to 1 upon 2 and cos theta will be equals to positive 3. Now, as cos inverse of a number greater than 1 is not possible, so we will not be solving this equation. Taking cos inverse of 1 upon 2, so cos inverse of 1 upon 2, when we substitute this in the calculator, the basic angle will be 60 degrees. Now, as the values of theta are from minus 90 to positive 90, so we might also have to find a negative angle. Now, we know that cos is positive in the first quadrant, so we'll make the basic angle 60 degrees. And when you're finding the positive angles, we measure the angle anti-clockwise from the positive x-axis. So the first angle for theta will be 60 degrees. To find the negative angle, we'll make the basic angle in the fourth quadrant, as cos is positive over here as well. But as you're looking for the negative angle, so we'll now measure the angle clockwise from the x-axis. So if we measure it clockwise, this answer will become minus 60 degrees. So the two values of theta will be 60 and minus 60 degrees. In question 2, the graph of y equals to f of x is transformed to the graph of y equals to f of 2x minus 3. We have to describe fully the two single transformations that have been combined to give the resulting transformation. Now, when we have a function f of x and when we write it as f of 2x, it means that there has been a stretch in the x direction, and the scale factor in this case, the scale factor will be 1 upon 2. And this minus 3 from the function, so if you have a function f of x and it becomes f of x plus minus a, it means there has been a translation, and the translation is in the y direction. So this will represent 0 and a. Now in this case, this is minus 3, so we'll write 0 and minus 3. So the two transformations, the first one is a stretch in the x direction, and the scale factor will be 1 upon 2. And the second transformation will be a translation with the translation vector 0 and minus 3, as there has been a movement of minus 3 units of the function in the y direction. In part B, the point P5, 6 lies on the transformed curve f of 2x minus 3. We have to state the coordinates of the corresponding point on the original curve y equals to f of x. Now, we know that for f of x, there had been a stretch in the x direction, which had a scale factor of 1 upon 2. So we know that if there was a stretch in the x direction and the scale factor was 1 upon 2, it means that the x value was half. So it means that the original value of x would have been 10. And as the translation was 3 units negative in the y direction, it means that the original point had moved 3 units down. So as the point P is 6, it means that originally it was at 9. So the original coordinates were 10, 9 for f of x. In question 3, the function f is defined as follows. F of x is equals to x plus 3 upon x minus 1 for x greater than 1. In part A, we have to find the value of f of 5. So to find this, f of 5 basically means that in the function f, we'll substitute in place of x the whole function x again. So in place of x, I will write x plus 3 upon x minus 1 plus 3 divided by, again in this x will substitute x plus 3 upon x minus 1 minus 1. Now as it is f of 5, so in place of x we'll substitute 5. So this will become 5 plus 3 upon 5 minus 1 plus 3 divided by 5 plus 3 upon 5 minus 1 minus 1. So the numerator will be 8 upon 4, 2. 2 plus 3 will become 5. And this is 8 upon 2 and 2 minus 1 will be 1. So the value will be 5. Now in part C, it says that find an expression for f inverse of x. Now to find an expression for f inverse, first we'll write y in place of f of x. So this will become x plus 3 upon x minus 1. Now exchanging the values of x and y, this will be x equals to y plus 3 upon y minus 1. Cross multiplying, we'll get xy minus x is equals to y plus 3. Now to make y the subject, we'll bring the y on the left hand side. So this will be xy minus y equals to 3 plus x. Taking y common, we'll get y bracket x minus 1 is equals to 3 plus x. So the final answer will be y equals to 3 plus x upon x minus 1. We can write this as f inverse of x is equals to x plus 3 upon x minus 1, which is basically the original expression for f of x. In question 4, a curve is such that dy dx is equals to 8 upon 3x plus 2 whole squared. The curve passes through the point 2 comma 5 wholes 2 upon 3. We have to find the equation of the curve. Now to find the equation of the curve, we'll have to integrate the expression for dy dx. Before integrating, we'll bring the 3x plus 2 in the numerator. So this will become minus 2. Now integrating both the sides, so integrating dy becomes y equals to 8 into 3x plus 2. The power increases by 1 and we divide by the new power. So this will be minus 1. And we also multiplied by the derivative of 3x plus 2. So this will multiply by 3. And then we add a constant over here. Now to find the value of the constant, we substitute the points 2 and 5 wholes 2 upon 3. So 5 wholes 2 upon 3 can be written as 17 upon 3 is equals to minus 8 upon 3 into 3 into 2 plus 2 to the power minus 1 plus c. Simplifying this, we'll get 17 upon 3 is equals to minus 8 upon 3 into, so to make this power positive, we'll bring it in the denominator. So this will become 6 plus 2, 8 plus c. This 8 and it will cancel out. So this will become 17 upon 3 plus 1 upon 3. So 18 upon 3 will be equals to 6. Once you have the value of c, we can write the final equation as y equals to minus 8 upon 3. And we can write the 3x plus 2 in the denominator to make it a positive sign. So this will be 3x plus 2 to the power 1 plus 6. In question 5, the first, third, and fifth term of an AP are 2 cos x minus 6 root 3 sin x and then 10 cos x respectively, where x is greater than half pi and less than pi. In part A, we have to find the exact value of x. So the nth term formula for an AP is given by a plus n minus 1 into d. As the third term is minus 6 root 3 sin x, so we can write this as minus 6 root 3 sin x will be equals to a, which is 2 cos x, plus n minus 1. So as n is 3, this will become plus 2d, making 2d the subject. This will become 2 cos x. So when we take 2 cos x on the other side, this will become minus 2 cos x minus 6 root 3 sin x. Dividing both the terms by 2, that will become minus cos x, and this will become minus 2 root 3 sin x. The fifth term is 10 cos x, so we can add another expression to make d the subject. So in that case, we'll write it as 10 cos x will be equals to the first term, which is 2 cos x plus, so 5 minus 1 will be 4. So this will become 4d. So 4d will be equals to 10 cos x minus 2 cos x. which is equals to 8 cos x. So d will be equals to 8 upon 4 cos x, which will be 2 cos x. Now equating the two expressions for cos x, we'll get for d, this will become minus cos x minus 2 root 3 sin x will be equals to 2 cos x. Taking the cos x on the other side, we'll get, so this will become minus 2 root 3 sin x. And so 6 divided by 2 in this case, there's a small mistake. So this would have been a 3 up here. As 6 divided by 2 is 3, so this would have been minus 3 root 3. So writing 3 over here, this will be minus cos x minus 3 root 3 sin x will be equals to 2 cos x. Taking the cos x on the other side, this will become minus 3 root 3 sin x is equals to 3 cos x. Now bringing the cos x on the left hand side, we can write it as sin x upon cos x is equals to 3 upon minus 3 root 3. 3 and 3 will cancel as sin x upon cos x is tan x. So the final expression will be tan x equals to 1 upon or minus 1 upon root 3. Now find for x, first we'll find the basic angle. So taking tan inverse of 1 upon 3 pi, that will be equals to pi upon 6. Now as tan is negative, we'll make this in the negative quadrants of tan. And as tan has to be from 1 upon 2 pi to pi only, and this is basically 1 upon 2 pi and this is pi. So we will make pi upon 6 the basic angle over here. So x will be this angle measured anti-clockwise from the x-axis. So x will be pi minus pi upon 6. So the value of x will be equals to 5 pi upon 6. In part B, we have to find the exact sum of the first 25 terms of the progression. So the sum formula for an arithmetic progression is given by n upon 2 into 2a plus n minus 1 into d. Now we know that n is 25, so this will be 25 upon 2 into 2 and a is cos x. So in place of x, we can now write 5 pi upon 6 plus n minus 1 is 24 and d was 2 cos x, so we can write it as 2 into cos of 5 pi upon 6. Simplifying, we'll get sum of n terms as 12.5 into, now cos of 5 pi upon 6 in the calculator is minus root 3 upon 2 plus this will become 24 into 2 into minus 3 minus root 3 upon 2. Simplifying, we'll cancel the 2's over here. This 2 will cancel with this 2. So sum of n terms will be 12.5 into minus root 3 plus, and this is a minus, so this will become a minus 24 root 3. Now simplifying this, sum of n terms will be equals to 12.5 into minus root 3 minus 24 root 3. And just for correction, a was 2 cos x. So in place of a, we had to write 2. So this will also multiply by 2. So minus root 3 will also multiply by 2. So this will be a minus 2 root 3. So minus 2 root 3 minus 24 root 3 will become minus 26 root 3. 12.5 multiplied by 26 will be equals to 325. So the final answer will be minus 325 root 3. In question 6, the second term of a geometric progression is 54 and the sum to infinity of the progression is 243. It's given that the common ratio is greater than 1 upon 2. We have to find the 10th term, giving our answer in exact form. Now the formula for sum to infinity is a upon 1 minus r, and for the nth term it is ar to the power n minus 1. Now as a sum to infinity is 243, so we can write this as 243 is equals to a upon 1 minus r. And as the second term is 54, so we can write it as 54 will be is equals to AR to the power 2 minus 1, which is equals to AR will be equals to 54. Now from the first equation, we can say that A will be equals to 243 into 1 minus R. And from the second equation, we'll get A equals to 54 upon R. Next, equating the two equations, we'll get 243 minus 243R equals to 54 upon R. Cross multiplying, this will become 243R minus 243R squared equals to 54. Bringing the terms on the left hand side to make R square positive, we'll get 243R squared minus 243 plus 54 equals to 0. Now, 243 can divide by, when we divide by 27, the answer is 9. So this will become 9R squared. We can substitute this directly in the calculator as well to get the values of R. So this will become 9R squared minus 9R plus 2 equals to 0. Factorizing this, so we'll get 9R squared minus 6R minus 3R plus 2 equals to 0. Taking 3R common, this will become 3R minus 2. And taking 1 common, we'll get 3R minus 2 equals to 0. So we'll get 3R minus 1 and 3R minus 2 equals to 0. So the two values of R are 1 upon 3 and 2 upon 3. As the value of R has to be greater than 1 upon 2 and 1 upon 3 is less than 1 upon 2, so we'll ignore this value and this value of R will be taken. Using this value of R, we can now find the value of A, which will be 54 divided by 2 upon 3, which can now be written as 54 multiplied by 3 upon 2. So this will become 27 into 3, which is equals to 81. Now we have the values of A and R. To find the nth term, we can use the formula AR to the power n minus 1, as A is 81. So we can write this as 51 into 81 into R is 2 upon 3 to the power 10 minus 1. So this will become 81 into 10 to the 2 upon 3 to the power 9. So writing 2 upon 3 to the power 9 in the brackets, this will become 512 upon 196. So we'll write it as 81 into 512 upon 19683. So multiplying this answer by 81, we will get 512 upon 243. So the 10th term will be 512 upon 243. In question 7, in the diagram, the lengths of AB and AC are both 15 centimeters. The point P is the foot of the perpendicular from C to AB. The length CP is equals to 9. An arc of a circle with center B passes through C and meets AB at Q. In part A, we have to show that angle ABC is equals to 1 to 1.25 radians. Correct to 3 significant figures. Now, ABC is an isosceles triangle as AB is equals to AC, which means that this angle ABC will be equal to the angle ACB. So if we can find this angle PAC, we can subtract it from pi radian and then divide by 2 to find the angle ABC. So to find this angle PAC, we can, as this angle has opposite 9 and hypotenuse 15, we can say that sine PAC will be equals to 9 upon 15. So taking sine inverse of 9 upon 15, this will be equals to 0. So PAC will be equals to 0.6435 radians. Now to find angle ABC, we'll subtract pi from 0.6435 and then divide by 2. So subtracting pi from the answer, this will become 2.498. And then dividing this answer by 2, the final answer will be 1.249. As we have to give our answer to 3 significant figures, the final answer will be 1.25 radians. In part B, we have to calculate the area of the shaded region which is bounded by the arc CQ and the line CP and PQ. Now to find the area of the shaded region, first we can find the area of the sector BQC. Then we can find the area of the triangle PBC and then subtract the two areas. Now to find the area of the sector, we need the length of BC, which will be the radius. As this angle is 1.25 and this is a right angle, so we can find the length of BC by using opposite over hypotenuse sign again. So to find the length of BC, we can write it as sine of 1.25 will be equals to 9 upon BC. So BC will be equals to 9 divided by sine of 1.25. So 9 divided by sine of 1.25, when we substitute this in the calculator, the answer will be 9 divided by sine 1.25 is equals to 9.438. 9.483. Once we have the length of BC, so this is the length of BC. So the area of the sector will be half r is given by half r squared theta. As the radius is 9.483, so this will be half 1 upon 2 into 9.483 whole squared multiplied by the angle theta, which is 1.25. Substituting this value in the calculator, the area of the sector will be 56.207 centimeters squared. Now to find the area of the triangle, we'll have to find the length of PB, and then we can use the area of the triangle half AB sine C to find half base into height. So to find the length of PB, we can use Pythagoras theorem. So PB will be equals to, so the hypotenuse is 9.483. So we'll do 9.483 squared minus the length of PC was 9. So this will be 9.483 squared minus 9 squared. So 9.483 whole squared minus 9 squared is equals to 8.9. So PB squared will be equals to 8.927. Taking square root of the answer, the length of PB will be equals to 2.987. So the area of the triangle will be equals to 1 upon 2 into 9 into 2.987. So multiplying the answer by 9 and then dividing it by 2, the area of the triangle will be 13.44. And finally, for the shaded region, we'll subtract the two areas. So for the shaded region, the final answer will be 56.207 minus 13.44. So 56.207 minus 13.44 is equals to 42.83. As we have to give our answer to three significant figures, so the final answer will be 42.8 centimeters squared for the area of the shaded region. In question 8a, it is given that in the expansion of 4 plus 2x into 2 minus ax to the power 5, the coefficient of x square is minus 15. We have to find the possible values of a. Now to get a coefficient of x square in this expansion, so 4 plus 2x will have to multiply by a term in x that will multiply by 2x to give us a term in x squared, and another term in x squared that will multiply by 4 to give us a term in x squared. So we'll have two terms, one in x squared and one in x, that will multiply by each of these terms to give us a term in x squared, and that will be equals to minus 15. Now the expansion formula for if we have an expression of the form 2 minus ax to the power 5, the formula is a power n plus nc1, a power n minus 1 b power 1 plus nc2 a power n minus 2 b power 2. Now in place of b, we have ax, and as we need power x and x squared, so we can use nc1 and nc2. So using 5c1, this will become 5c1 into, now as there's a negative sign over here, so we'll have to be careful about that. In place of a, we'll write 2, and this will become 5 minus 1. And as b is minus x over here, so we'll write minus x to the power 1. So 5c1 is 5, and 2 to the power 4 will become 16. So that will become 5 into 16 into minus ax. So 5 into 16 is 80. So this will be minus 80 ax. And now for the term for x squared, we'll do 5c2. 2 to the power 5 minus 2 into minus ax to the power 2. So 5c2 in the calculator, that will be equals to 10 into 2 cube, and this will be equals to a squared x squared. The negative sign will cancel out. So 2 cube is 8. 8 times 10 is 80. So this will become 80 a squared x squared. So now we can multiply the expression. We have 4 plus 2x, and the terms for in x is minus 80x, and the term in x squared is 80 a squared x squared. Now multiplying these expressions, so this 2x will multiply by minus 80, so this will be minus 160x, and 4 will multiply by 80 to give us 320 a squared x squared, and that will be equals to minus 15, as the coefficient of x squared was minus 15. Taking x squared common on both the sides, we'll get minus 60 plus 320 a squared is equals to minus 15 x squared. We can cancel out the x squared terms and now compare the values. So we can write this as 320 a squared will be equals to minus 15 plus 160. So 320 a squared will be equals to 145. And now dividing 145 by 320, so that will be equals to, so 145 divided by 320 in fraction, that is equals to 29 upon 64. So this will be minus 15 plus 160. Okay, so there was a 160a up here. So this was 80ax, and this would have been an 80a as well. So 80 multiplied by 2 would have been 160x squared. So 160ax squared. So this would have been a as well, and we would have to add an a up here as well. So correcting this first initially, because this was an 80ax up here, so this will be minus 80ax. So writing it as minus 80ax, and now writing the expression again, so this will be equals to, so 4 into 80a squared x squared will be 320a squared x squared, and this will be minus 160a x squared equals to 15x squared. This was a minus 15. Now taking x squared common, we'll get 320a squared minus 160a is equals to minus 15x squared. So this expression will become 320a squared minus 160a plus 15 equals to 0. Factorizing this, we'll get 8a minus 3 in the calculator and 8a minus 1. So the values of a will be equals to 1 upon 8 and a will be equals to 3 upon 8. In part B, it says that it is given instead that in the expansion of 4 plus 2x and 2 minus ax to the power 5, the coefficient of x square is k. It is also given that there is only one value of a which leads to this value of k. We have to find the values of k and a. Now we already have the expansion for 2 minus ax. The two terms were minus 80ax and the x squared term was 80a squared x squared. So multiplying the expressions, instead of the coefficient in this case will be equals to k. So multiplying 80 by minus 80x by 2, that will be minus 160ax squared. 80a squared x squared with 4, that will become a 320a squared x squared will be equals to kx squared. So taking x squared common, this will be minus 160a plus 320a squared is equals to kx squared. So the the x squared terms will cancel out, and we can now compare the coefficients. So this will be 160 a plus 320 a squared is equals to k. We can write this expression as 320 a squared minus 160 a minus k equals to 0. Now, as we have a quadratic expression and there is an unknown constant, we can now apply the discriminant. So this will be b squared minus 4ac, and it will be equals to 0, as there is only one value of a. So the b value will be minus 160, the a value is 320, and the c value will be minus k. Now substituting this into b square minus 4ac, this will be minus 160 whole squared minus 4 into 320 into minus k equals to 0. We can rearrange this to write it as 160 whole squared is equals to 4 into 320k. Solving this, so 160 whole squared, and then we'll divide it by 4 into 320. So the value of k will be equals to, so this will become a plus over here, and when we take it on the other side, this will be a minus. So the value of k will be minus 20. Now, once we have the value of k, now we can substitute this into the equation to find the value of a. So this expression for this, in this expression, we'll substitute the value of k. So this will become 320a squared minus 160a, and k is minus 20. So this will become a plus 20 equals to 0. Dividing the expression by 20, we will get, so this will be 16a squared minus 8a plus 1 equals to 0. We can write it as 16a squared minus 4a plus 1 equals to 0. Taking 4a common, we will get 4a minus 1, and taking 1 common, we'll get 4a minus 1 up here. Simplifying, we'll get 4a minus 1 and 4a minus 1. So the value of a in both cases will be, a will be equals to 1 upon 4. In question 9, the volume V meter cube of a large circular mound of iron ore of radius r is modeled by V equals to 3 upon 2 into r minus half whole cube minus 1 for r greater than equals to 2. Iron ore is added at a constant rate of 1.5 meter cube per second. Find the rate at which the radius of the mound is increasing at the instant when the radius is 5.5. Now, the relationship between the volume and the rate of change of volume and the rate of change of radius will be dv by dt equals to dv by dr into dr by dt. Now, as iron ore is being added at a rate of 1.5, so we know that dv by dt will be equals to 1.5. So this is already given to us as 1.5. As we need to find the rate at which the radius is increasing, so dr by dt is unknown. Now, to find this value, we have to find the value of dv by dr. So to find dv by dr, we'll first differentiate the expression for v. So v is equals to, v is equals to 3 upon 2 into r minus 1 upon 2 to the power 3 minus 1. Finding dv by dr, so multiplying 3 by 3, that will become 9 upon 2 into r minus 1 upon 2. The power will decrease and become 2. And the derivative of 1 is 0. And the derivative of r minus half is also 1. So we'll just multiply it by 1. The expression will be 9 upon 2 into r minus half to the power 2. Now, as the value of r is 5.5, so we can write it as 9 upon 2 into 5.5, and 1 upon 2 is 0.5 whole squared. Now, substituting this in the calculator, so this will be 25 into 9 divided by 2, which is 112.5. So the value of dv by dr will become 112.5. Finally, to find the value of dr by dt, so dr by dt will be equals to dv by dt divided by dv by dr. We already have the value of dv by dt, which is, so it is given as 1.5, and dividing it by 112.5. So this will become 1 upon 75. Substituting this in the calculator, the value of dr by dt will be equals to 1 upon 75 meters per second. In part B, it is saying find the volume of the mound at the instant when the radius is increasing at 0.1 meter per second. So in this part, we already have the expression for dV by dr. So dV by dr was equals to 9 upon 2 into r minus half whole squared. So this is 9 upon 2 into r minus 1 upon 2 whole squared. Now, in this case, we have been given the value of dr by dt. So dr by dt is 0.1. And as we have to find the volume, the dv by dt is also equals to 1.5 as given in the question. So we need the value of dv by dr. So using the expression again, dv by dt is equals to dv by dr into dr by dt. To find the expression for dv by dr, that will be equals to dv by dt divided by, so this will go on the other side and this will be dv by dt divided by dr by dt. So that will be 1.5 divided by 0.1, which will be equals to 15. Once we have the value of dv by dr, we can now find the value of r and then substitute it into the original expression to find the value for v. So as dv by dr was 9 upon 2 into r minus 1 upon 2 whole squared, so we can equate it equals to 15. So 15 will be equals to 9 upon 2 into r minus 1 upon 2 whole squared. Cross multiplying, this will become 30 upon 9. So 2 will multiply by 15 divided by 9 is equals to r minus 1 upon 2 whole squared. Taking this, so we can write it as 10 upon 3. So r minus 1 upon 2 will be equals to square root of 10 upon 3, as we'll take the square root on both the sides. And then finally the value of r will be square root of 10 upon 3 plus 1 upon 2. Once we have the value for r, we can now substitute it into the original expression to find the volume. So the original expression for volume was 3 upon 2 into r minus half whole cube minus 1. So this was 3 upon 2 into r minus 1 upon 2 whole cube minus 1. Substituting the value of r over here, so substituting square root of 10 upon 3, so this will be 10 upon 3 and plus 0.5, that is equals to 2.325. We'll subtract, so we can write it as 3 upon 2 bracket 2.325. As when we substitute this in the calculator, this will be 2.325 minus 0.5 whole cube minus 1. So this answer minus 0.5, and then we will whole cube the expression. So, and then multiplying it by 3 and dividing it by 2 and then subtracting 1, the final answer for the volume will be 8.13 centimeter cube. In question 10, the function f is defined by f of x equals to x squared plus k upon x plus 2 for x greater than 0. In part A, it says given that the curve with equation y equals to f of x has a stationary point when x equals to 2, we have to find k. Now, for the stationary point, we know that the derivative or f dash of x will be equals to 0. So in the first step, we can first write the expression as x squared plus k x to the power minus 1 plus 2. Now, when x is 2, the dy dx will be 0. So first finding the expression for the derivative, that will become 2x. Minus 1 will multiply by k and the power will decrease by 1 and the derivative of 2 will be 0. So we can write the expression for f dash of x as 2x minus k upon x squared. Now substituting 0 in place of f dash of x and x equals to 2, this will become 4 minus k upon 4. So we can write it as k upon 4 will be equals to 4. So the value of k will be equals to 4 into 4, which is 16. In part B, it is saying determine the nature of the stationary point. So for the stationary point, we'll have to find f double derivative of x. Now to find this expression, the expression for f dash of x was equals to 2x minus k upon x squared. So this will be 2x minus, we can write it as 16 upon x squared. Writing it as 2x minus 16x to the power minus 2. And then differentiating this, we'll get, so the derivative of 2x will be 2, minus 2 into 6, minus 16 will be a plus 32, x to the power minus 3. So we can write it as 2 plus 32 upon x cube. Now the value of x was 2, so substituting 2 in place of x, we'll get 32 upon 2 cube, which will be equals to 2 plus 32 upon 8. 32 upon 8 is 4, so this will be 6. As f dash of x in this case is greater than 0, we will say that it will be a minimum point. In part C, it is saying, given that this is the only stationary point of the curve, find the range of f. Now, from the expression, we know that the minimum point was at x equals to 2, and f of x was x square plus k upon x, so that will be 16 upon x plus 2. Now the minimum point was at x equals to 2, so to find the range of f, as it is a quadratic function and it has a minimum point, so we have this x value, and for the range we have to find the y value. So substituting x equals to 2, this will become 2 squared plus 16 upon 2 plus 2. So this will become 4 plus 8 plus 2. So f of 2 at the minimum point will be equals to 8 plus 4, 12 plus 2, 14. Now, as this is a minimum point, all the values of the function will be above this point. So we'll say that f of x will be greater than or equals to 14. In question 11, the diagram shows a line x equals to 5 upon 2, part of the curve half x plus 7 upon 10 minus 1 upon x minus 2 power 1 upon 3, and the normal to the curve at the point A, which is 3, 6 upon 5. In part A, we have to find the x-coordinate of the point where the normal to the curve meets the x-axis. Now, at this point, the coordinates will be x, 0. To find the x-coordinate, we will first have to form an equation for the normal. Now, before we form the equation, we need to find the gradient. So first we'll find the dy dx of the expression. So initially we can write this expression as 1 upon 2x plus 7 upon 10 minus x minus 2 to the power minus 1 upon 3. So finding the dy dx, which will give us the gradient of the tangent, this will be 1 upon 2. So differentiating 1 upon 2x will be 1 upon 2, 7 upon 10 will become a 0. Now multiplying minus 1 upon 3 by minus, this will become a plus 1 upon 3 into x minus 2, and minus 1 upon 3 minus 1 will be equals to minus 4 upon 3. So this will be minus 4 upon 3. Now the x value at point A is 3, so this will become 1 upon 2 plus 1 upon 3 into 3 minus 2 to the power minus 4 upon 3. So 1 to the power minus 4 upon 3 will be 1. So the gradient will be 1 upon 2 plus 1 upon 3, which will be equals to 5 upon 6. Now the gradient of the tangent is 5 upon 6, as the dy dx gives the gradient of the tangent. So the gradient of the normal will be equals to the negative reciprocal, which is minus 6 upon 5. Now forming the equation of the normal, which will be formed using the formula y minus y1 equals to m into x minus x1. So the y1 value will be 6 upon 5. So we'll write y minus 6 upon 5 equals to, the gradient is minus 6 upon 5. So this will be minus 6 upon 5 into x minus the x1 value will be 3. So taking the LCM, this will become 5y minus 6 upon 5 equals to minus 6x plus 18 upon 5. The 5 and 5 will cancel on both the sides. So the final equation will be 5y equals to minus 6x plus 18 plus 6. So this will be 5y equals to minus 6x plus 24. Now to find the x coordinate, we'll now substitute y equals to 0 into the equation. So when we substitute y equals to 0, this will be 0 is equals to minus 6x plus 24. So 6x will be equals to 24 and x will be equals to positive 4. So this point will be 4, comma 0. Now in part B, we have to find the area of the shaded region, giving the answer correct to 2 decimal place. Now to find the area of the shaded region, we have the curve and the normal intersecting at point A. So we will use this point to find the area under the graph for the equation y equals to half x plus 7 upon 10 minus 1 upon x minus 2 whole cube. This x value is 3, so the limit will be 3 and 5 upon 2 for the curve. And then for the triangle, we can use half base into height. The base is 1 and the height is 6 upon 5. So we can do half into 6 upon 5 into 1. Now, first finding for the area under the curve, the equation is y equals to 1 upon 2x plus 7 upon 10 minus 1. So we can bring x minus 2 to the power minus 1 upon 3 in the numerator. Now integrating to find the area, we'll get, so integrating 1 upon 2x, this will become 1 upon 2x squared upon 2, which will be equals to x to the power 4 upon 4. So this will become x squared upon 4 as we increase the power and divide by the new power. This will become 7 upon 10x. And now increasing the power by 1, so x minus 2 minus 1 upon 3 plus 1 will become positive 2 upon 3. So this will become 2 upon 3 and we'll divide it by the new power 2 upon 3. So this will be x squared upon 4 plus 7 upon 10x minus 3 upon 2 into x minus 2 to the power 2 upon 3. Now substituting the limits, as the limits were 3 and 5 upon 2. So first substituting the upper limit, which is 3, so this will become 9 upon 4 plus 7 upon 10 into 3 minus 3 upon 2 into, so 3 minus 2 will be 1. So this will become 1 to the power 2 upon 3. And then subtracting the lower limit. So the lower limit was 5 upon 2. So this will become 5 upon 2 is 2.5. So we'll write 2.5 whole squared upon 4 plus 7 upon 10 into 2.5 minus 3 upon 2 into 2.5 minus 2 to the power 2 upon 3. Substituting these values in the calculator, so this will become 9 upon 4 plus 2.1 minus 3 upon 2 minus, this will become 6.25 upon 4 plus 1.75 minus 3, and this will 2.5 minus 2 will be 0.5 to the power 2 upon 3 divided by 2. Subtracting the values in the calculator, the area under the curve will be 0.48. And now finding the area of triangle. So this will be 1 upon 2 into, so now we know that the base will be 1 and the height will be 6 upon 5. So we'll write it as 1 upon 2 into 1 into 6 upon 5, which will be equals to 6 upon 10. Or in decimal, we can write it as 0.6. So the total area will be equals to 0.6 plus 0.48, which is equals to 1.08. So the final answer will be 1.08 for the area of the shaded region. In question 12, the diagram shows a circle with equation x squared plus y squared minus 6x plus 4y minus 27 and the tangent to the circle at the point 5, 4. The tangent to the circle at P meets the x-axis at A and the y-axis at B. So at x-axis, the coordinates will be x, 0, and at B, the coordinates will be 0, y. We have to find the area of the triangle OAB, where O is the origin. Now to find the area, we have to find the x coordinate and the y coordinate and then apply half base into height to find the area of the triangle. For these coordinates, we need to form an equation for the tangent. Now we know that the center from the equation, which is x squared plus y squared minus 6x plus 4y minus 27 equals to 0. We can deduce that the center points will be 3 and minus 2. So as the general equation for the circle is given by x squared plus y squared minus 2ax minus 2ay minus 2by plus a squared plus b squared minus r squared equals to 0. So we can compare the coefficients. So a will be minus 2a will be equals to minus 6. So a will be equals to 3 and minus 2b will be equals to 4. So b will be equals to minus 2. Now these are the center points of the circle. So the center points are 3 comma minus 2. Now as we have the coordinates of the center, which is 3 comma minus 2, so if we can find the gradient of CP, the gradient of AB will be a negative reciprocal. So we already have the coordinates of P. This is C, and the coordinates of P is 5 comma 4. Finding the gradient of CP, that will become 4 minus minus 2 upon 5 minus 3. So this will be 6 upon 2, which is equals to 3. Now, as this is the gradient of CP, gradient of AP will be a negative reciprocal. So the gradient of the tangent will be equals to minus 1 upon 3. Forming the equation, this will become y minus y1. So we already have the coordinates of point P, which is 5 comma 4. So this will be y minus 4 is equals to minus 1 upon 3 into x minus 5. Now finding the coordinates of A, we will substitute y equals to 0. So this will become minus 4 is equals to minus 1 upon 3x minus 5 or plus 5. Plus 5 will go on that side and become minus 4 minus 5, which is minus 9 is equals to minus x upon 3. And the x coordinate will be equals to 27. So this 5 should have also multiplied by 1 upon 3, and this would have become a plus 1 upon 3 plus 5 upon 3. So minus 4 plus 5 upon 3 will now become, so this will be minus 4 plus 5 upon 3 is equals to negative 1 upon 3x. So minus 4 plus 5 upon 3 will be minus 12, and this will become a negative. So this will be minus 17 upon 3 is equals to minus 1 upon 3x. 3 and 3 will cancel. So the x coordinate will be equals to 17. Once we have the x coordinate, for the y coordinate of point B, we will substitute x equals to 0. So this will be y minus 4 is equals to minus 1 upon 3 into minus 5. So y will be equals to plus 5 upon 3 plus 4. Simplifying this, we'll get 3 times 4 is 12. So 12 plus 5 is 17. So that will be 17 upon 3. So this point is 17 comma 0. And this point is 0 comma 17 upon 3. So we can say that the height is 17 upon 3 and the base is 17. So we can write that the area will be equals to 1 upon 2 into 17 upon 3. So the final answer will be 289 upon 6 for the area of the triangle OAB. In part B, it says that points Q and R also lie on the circle such that PQR is an equilateral triangle. We have to find the exact area of triangle PQR. Now, as PRQ is a triangle, so let's first make a line to join the points and form a triangle. Now, to find the area of the triangle, what we can do is we can divide it into 3 parts. From the center to each of the parts, if we can find the area of each of these, as these triangles are exactly the same, so we can find the area of one triangle and multiply it by 3. Now, in the first step, we'll have to find the length of CQ. So CQ is the radius, and we know that a square plus b square minus r squared will be equals to minus 27. So in the first step, we'll find the radius as a squared plus b squared minus r squared is equals to minus 27. we already have the values of a and b, which were 3 and -2. So this will become 3 squared plus -2 whole squared minus r squared equals to -27. So this will become 9 plus 4. And then we can bring the 27 on this side. This will become a plus 27 equals to r squared. So we can say that the radius will be 27 plus 13, 40. So that will be square root of 40. For the angle RCQ, now we know that as it's an equilateral triangle, each of these angles will be equal. This total angle will be pi upon 3, and this angle will be, this complete angle will be pi upon 3, and this angle will also be pi upon 3. Now, applying the circle property that the angle at the center is twice the angle at the circumference, so we know that this angle will be 2 pi upon 3 or 120. So if this angle is 60 or pi upon 3, this angle will be 20 or 2 pi upon 3 in radians. So now finding the area of the triangle, we will write it as half AB sine C. The radius is square root of 40, so this will be square root of 40 whole squared multiplied by sine of 2 pi by 3. And as there are three similar triangles, so the total area will be equals to 3 into half. Square root of 40 whole squared will become 40, and sine of 2 pi by 3 will be root 3 upon 2. Simplifying this, the total area will be, so this will cancel with 40 and this will cancel with 20. So this will become 30 root 3 for the total area of the triangle.